Hello everybody and welcome back to another forecast. I'm now at the video that I did promise yesterday, so really though I'm going to be looking at the Midwest, more specifically Illinois, just because that's where I live and that's what my interest is in this point. Real quick though, I am going to look at this enhanced risk for today, as well as the enhanced risk for tomorrow, but this is included in the Illinois segment, so I'll look at this as well. But I do want to focus a little bit more on Illinois today, just because I want to understand what we could see, and mostly for my own weather enthusiasm. I quite like trying to get lightning if I can, so I want to understand how I can more accurately actually get some good lightning shots. So right now our pattern, I was looking at some of the information here. So I'll go back to the 500 millibar level, so you can see our weather pattern. I did talk about this in yesterday's video, but we have our polar jet stream and our subtropical jet stream. What they're going to do, they're meeting together here. You can kind of see they fuse, blows combine, and it gets a lot stronger. And this trough ejection goes on. So Monday is kind of our day before the day, right? Today is at storm hour 0Z, that's 7 p.m. Central Time. You can see going on, you have this low pressure, but it's not super well defined in any specific area. There's not really too many short waves. You have stronger flow down here in Arizona, but that's not where you're going to see any of your moisture really taking place at all. It's very dry air, and all the moisture is over here in like Kansas, Nebraska, all that Great Plains. What you have to do is look at the surface here, and again, our main threat is going to be evening tornadoes, I believe, or sorry, evening wind and hail damage. Let me get my SPC outlook here. Small 5% here around the basis of that trough where the moisture is better. You have a very broad 2%, I think, because there's enough possible rotations with the stronger updraft. So it's very marginal, but it could happen in any of that area. Seems to be wind and hail, though, as SPC is outlined here, which makes sense. We're going to see probably a little bit of a remnant line. Look at the HRRR, and this will show us reflectivity, which is very nice. Right in that vicinity, you can see here, there's your strong cells, a few strong supercells, likely hail producers, but if they congeal enough, they could get some decent wind damage. You can see the small semblances of Boeing, like little Boeing segments maybe. They could have definitely strong wind damage to come with them. That's part of why the SBC has this hatch region. Wait, edit this up a little. Part of why they have that hatch region. But I look at the RAP model, like I'll take a sounding from near here, just so you can kind of see the air environment. I take a drink coffee as well. This should show us our CUT and our hodograph. I would take somewhere else, but honestly, there's not much else to look at besides Illinois. Now, our hodograph is actually pretty good for supercells. You have good low-level shear, so this is why we have that tornado threat. You can see our wind barbs here directly out of the east, so that's gonna help back any flow and any supercells that form. Decent mid-level cape here, so the main thing is it's an all hazard risk, but it depends on storm mode a lot. So there's enough um like hail growth zones as these two -20 degrees Celsius and 0 degrees. And you look at our cape. Let me get my pen out real quick. You get your cape right here. Bring this over. Right. Get your cape in this vicinity, and that's decently fat. So pretty good cape in where you want to see it for hail. Not to mention lots of speed share along this entire hodograph, right? So as you go up with height, you're kind of moving off to the east. So if there's too many cells affecting tornado potential, they could end up growing on themselves and going east quickly. That's kind of that's where you get your squall lines coming from. However, also the fact that we have good shear in the lower levels and up to the 1 kilometer level, we have a pretty good angle here, right? You can see all this curvature right in that 0 to 1, and then up to the 3 kilometer as well. Lots of curvature, lots of streamwise vorticity for this any supercells to ingest. Not to mention lots of warm advection you can see right here. Good for your cells. It's very late in the night, however, so 60 is pretty late, but nocturnal storms could definitely be a risk for the event. So here's all your supercells. I think I'll take a sounding from this side as well with these other growing cells. I want to match up with HRRR. HRRR doesn't give us direct information. Actually, this is an old HRRR, so you can see how they kind of upgraded as the day's going on here. It's definitely more of a nocturnal threat, though, from what I can understand. Also, for our Midwest sector here, another thing I wanted to look at is there's a small wind damage threat according to the SBC. Right here, 15% wind damage. Not half or anything, just a possibility. of a squall line forming right here. This current run of the HRRR, which is very recent, actually is still loading. This shows a little line segment right here. So this is a little more east than we had expected, but it is still there. If you look at the 12Z model, you should see it a little bit better for maybe for the Illinois segment. Again, this is also a fairly, excuse me, this outlook was a little bit old. I think the HRRR was still coming in at this point, but this is our main area for possible wind be going on. Our main forcing here is another little tiny surface low, I'm pretty sure. So here at 819Z, a very strong southerly flow out of the south that's bringing good moisture. Here's our surface low sign right here. And what could happen is just this cold front coming through around here. You can see colder temperatures in this half and warmer in the other half. Might be able to see it better on the dew point as well. Yeah, you can, kind of weird to see. You see how the dew points kind of get stretched to the east almost. You can imagine that as being the forcing of the cold front. You can see right here as well, that's where your convection starts. Your convection will probably form somewhere around here. And that outflow will push it to the east, kind of becoming your Boeing line segment, squall line. Wouldn't be surprised if this little 15% actually gets stretched a little more east, because honestly, that's where it looks to be, is all this wind damage here in Indiana possibility. So again, this is very conditional still. There's not much cape to go on with it, and that's my interest for that. I like the Rat model might have better cape. The Rat model is a lot better cape for this system, so that could lead to more wind damage forming the Illinois sector. I'll take a sounding. We'll just go right here in the center, and we'll do. We can do one more for that evening hours right here. Not really what I wanted to do, but it is what it is. Here is our sounding from those cells in the southeast Nebraska portion. I did realize I did forget to look at 3 Cape for this one. This is our soundings for the cells that were forecast in this Colorado area where our enhanced risk is. We go back. Oh, sorry, Nebraska. Let's see. Let's do the HRRR for simulated reflectivity. These early cells, that's where I was looking at. These cells are what this photograph is. And you do see a lot more capping in these lower levels. I forgot to mention that. 119 caps. So it could be kind of hard to break through, but any convection that does eventually form could be very potent. For a situation in the Nebraska vicinity, same thing. Strong cap will still be in place, but anything that can break through will be in a nice environment. 3 cape is a lot higher in this system. Cape's a lot lower, so less hail for this, and that's likely why we don't have nearly as large a risk for that area. However, there's still all hazards threat for these storms here. Go back to this sounding, and you have that shear again, that lower levels, but not super well jetted off either, and not a bunch of inflow. So a little less good for supercells, and that's why we have this structure here. That's our enhanced risk, and this is more of our slight marginal risk. These are Illinois storms. Again, they have a lot more cape to work with. According to the wrap here, pretty fat cape and maybe some hail. You do like to see the wet bulb temperature actually also goes down, so that could help with speed shear issues. Just any storms will have good outflow. That wet bulb, the outflow here will be much colder than the temperature, so that could help with the outflow boundaries and possible reformation of those storms. Also, no cap in this environment too, according to the wrap. I think the wrap might be a little bit extreme though. The photograph is not very good, but you can see how it kind of more of a multicellular mode where it's all kind of stacked up on each other. You know, all of the vectors, they're kind of going right on top of each other. Slight speed shear, but otherwise not really what you want to see for severe weather. But the multicellular mode could lead to that additional little line segment. This is our later sounding as well. Same thing, kind of some speed shear, but nothing really too extreme. There's more 3 cape in this sounding, but either way, there's not a bunch of cape to work with. That is mostly why it's more conditional for this Midwest sector. Let me delete all these soundings now because we're going to look into the next day of Tuesday. That is our secondary day, and I believe it's a much more significant day. I'll take the wrap model again, get our all 50 states, look at the 500 millibar. The Monday issue is that there's not really a good flow above the surface, right? You can see there's widespread flow, but it's not super well defined. It's not like it's a well-defined shortwave anywhere. Tuesday, however, this is when the trough ejection begins. So you can see a much stronger flow here over Iowa, Missouri, Kansas. So you can see this 70 knots of flow, and even very wide plume of 50 knots of flow across that whole area. 18Z, this is 1 p.m. Central Time, and that's when our storms are going to ignite. You can see again, just a bunch of flow is going with this trough, and even into the overnight hours, that still maintains itself all the way until about 10 p.m. Still, you have some 50s knots of flow in some of these areas too. Yeah, so our main ejection happens right in the middle of the day, right when storms are beginning to form. So that should help those storms really get going, and forcing will definitely be there. I look down to the surface. Our main thing going on is going to be this surface low. So starting right here, very well defined here. I don't have to highlight it. You can see it all rotating around 996 millibars, and this continues to strengthen throughout the day until it begins to occlude up here into Minnesota. 992 millibars, and even up to 990 even. Very well defined surface low here. Again, that occlusion too could lead to some warm front things, and that's something I want to look out for myself. So a warm front I would consider draped right about here. Actually, I'll look at the dew points for seeing this better, because you can see the temperature gradient is not very extreme. It's also kind of a weird boundary, in my opinion, right? So when I'm looking at the system, even yesterday, there's this weird, almost reverse dry line over northern Illinois right here. You can see on one half you have slightly higher dew points, and the other half you don't. The interesting thing is that the air is being moved north, so these larger dew points that have been building in are actually going to get like pushed upward into Wisconsin. And that's part of the reason we're seeing a higher tornado risk up here. Actually, let me look it up real quick. I believe the Colorado State Machine Learning Program is also seeing that risk in Wisconsin. This is today's outlook, day 2. See, it has a highlighted area. Here, I'll zoom in a little bit. Imagine this is SPC's probabilities. This is a very large tornado risk according to the machine learning program, and a very broad, like 15% region, and a specific area up here in Wisconsin of greatest probability for tornadoes. And that kind of makes sense looking at our forecast. All these dew points are larger here in the northern Illinois. What they're going to do with the surface low as it's occluding is get pushed up here. There's kind of a dry line on this half, just a huge, nice triple point, a very good warm sector here for tornadoes. I'll look at the HRRR as well. This will show us, I think, something similar. Not as extreme of that moisture surge. You can see here, right in that triple point along this corridor, that's where you'll see all that moisture kind of keep itself until that cold front sweeps through. So that's interesting to see. I'll look at the Cape as well. I don't want to forget everything. There's a lot of things to look at with severe weather like this. You can see that little push up here with the HRRR. Not as much Cape as the other models. The RAP shows us a lot larger and a lot more destabilized in the Wisconsin area. The NAM does this as well. NAM NST is the high resolution model for the NAM. A little less extreme as the NAM though, but again, that northern option is definitely very well defined. I'm going to combine the HRRR and the RAP model again here. Look at simulated reflectivity. And you can see our storms are starting to fire right around that time that trough ejection comes. So right around 18Z, 19Z, that's what I was talking about. Here's your storms firing. Take a RAP model from these storms right around here. Honestly, I could also do this on pivotal weather maybe, so I might end up doing that. And another formation here. Take another sounding. That should work. Right there. Got push wrong time frame. Let's see here. Right here at that hour. That's kind of potent. Very many supercells in a line right there. Very worrying for that. Here are sounding from here in Nebraska, and that first line of supercells, much more wind damage based, lots of speed shear, not really much turning, but if you look at the storm relative photograph, you could end up seeing that. Very fat cape. Definitely also a hail risk here with how that's incredible cape here. Lifted indexes are very large. So lots of cape in that hail growth zone, so you could see some very large hail with this. Analogs aren't really showing anything though, which is interesting to note. Here's another sounding from the Missouri, that big line, and you can see photograph the potential hazards PDS tornado, which is already kind of incredible. A very good shear back here, getting off of winds, lots of cape, 3 cape, not super high 3 cape, but still uncapped, and anything with 4,000 joules per kilogram is going to explode. Interesting to see. Actually, I'm going to look at pivotal weather just because it's going to be a little bit more convenient for looking reflectivity to soundings. Go to the we'll just use the 12Z model for now. A lot more easy to look at. And we'll look at this lower level reflectivity. Yeah, we're looking at the same product again. It's just on a different viewer. Look at that line. These are all supercells, basically supercellular in nature. Pretty sure updraft helicity here is also kind of through the roof, which is also something I want to look at here real quick for my own forecast, which I want to look at in Northern Illinois. This is the HREF. This is the High Resolution Ensemble Forecast, where they take a bunch of cams, which is it's convective allowing models, where they take into account convection and how that affects everything else. And look at updraft helicity and the probabilities of this. So I'll click this up and see these little contours get pushed in here. This is just saying where there's going to be updraft helicity, which is rotation, and what probability there is. Very interesting to see that right there. Let's look. Yeah, as you can see here, very wide range of 50% probabilities. Some of them even showing 70% later on. You can just see all that updraft helicity across this whole area. HRRR is very specific about this too. You can just see a huge swaths of updraft helicity. You can even see on here, kinda. Oh, bottom. HRRR, 6-hour updraft helicity. So last, see if that storm's forming, just a huge swaths, huge area where you could see updraft helicity. Not super strong in any specific instances. Definitely a very large area of updraft helicity. See it here as well. Lots of updraft helicity across this whole area. So definitely a potent setup according to the HRRR. Go back here again. Before, let's take a sounding ahead of these storms. Again, you can just see the environments by looking at these. You have that shear, again, not as well in this case, but kind of inverted V, very large spread. So our better option is going to be in that northern option where you're better with better moisture and lower temperatures. Last thing I want to look at is going to be the overnight line of storms. I want to see what it looks like ahead of that. See if there's any shear, and definitely lots of shear here actually. But I think that the storm mode is going to be unfavorable, especially for these 3 supercells. So that's my look at our systems. Hopefully I can get some good shots of either day, honestly. I like lightning. Unfortunately, I don't think there's anything much really in there. They actually just added a tornado risk. Oh, wow. I'll update this on my media post. Actually, this is completely fresh. This is like 12 minutes ago when I started this video. They just added a 5% tornado risk to this region. Let me look at that real quick, actually, or end the video. I was about to end the video, but if they added 5% tornado risk, it's also interesting. So let's look at the wrap model. There's that cape, actually. This is kind of what I was talking about. I was interested in this vicinity, right? I looked at this earlier. Surface temperature, slight surface low forming right here. You can see the rotation right here, and you can see the southerly flow up into this. It's actually this might be the Chicago Metro, or it's close to the Chicago Metro. It's more Wisconsin. There's that surface low early on, so you can even see right here, the surface low beginning at 15Z. It's there, and it moves up into the northeast, right along that line. Builds on right in this arrow. Bring up moisture. Oh yeah, nice moisture in there too. Let's just take one sounding from right in there. Could get one discrete supercell in there. Yeah, there's your reflectivity. You have a few updrafts joined together. And you could see some tornadoes up in there too. I understand the 5% now. Very interesting. Looks a little bit convectively enhanced, but the not the best for supercells. I'm assuming that they're gonna like a line segment forming. Yeah, lots of surface vorticity in here. Lots of that's so much. Lots of surface vorticity. And some through cape moving up into there should help anything maybe form a few tornadoes in there. So price 5% I wanted to look at. Otherwise, I might update on the community post later, but that's it for this video. Kind of went crazy on all the websites. I'm trying to understand different models, different viewers as well. Because one thing I think I've failed to look at for my last forecast was I would just look at the wrap, the NAM, and the HRRR and say, do they match? Yes or no. And if they did match, I said, okay, cool, it's an accurate forecast. However, these are not the only models, and sometimes maybe they are actually all the outliers. That's why I'm going to try using this HREF ensemble viewer a little bit more. See if it'll show me if it's anything good. So with that, thank you for watching. I hope to be improving the channel a little bit more in the future, but that's our main video for today. Interesting setups. I am back after graduating, so thank you for watching. I'll see you in the next video, and stay posted on community posts because I'm going to try to update those more as well. See you all.